What if China's biggest threat to America in artificial intelligence is not building a better AI model, but making powerful AI so cheap and accessible that being the best simply stops being as valuable as it used to be? For the last few years, the global AI race seemed almost predictable. The United States had the biggest technology companies, the most advanced semiconductor ecosystem, enormous amounts of capital, world-class researchers, and some of the most powerful AI models ever created. The strategy was straightforward: build larger data centers, buy more GPUs, train larger models, spend billions of dollars, and then turn that enormous investment into AI systems powerful enough to justify even more investment. Companies like Nvidia, Microsoft, Google, Amazon, OpenAI, and Anthropic became central players in an economic machine built around one basic assumption: more computing power would lead to more intelligent models would lead to better products, and better products would eventually create enormous profits. By 2026, the scale of this investment had become almost difficult to imagine, with four major American technology companies expected to spend roughly $750 billion on AI-related infrastructure and development during the year. That money goes into GPUs, data centers, electricity, cooling systems, networking equipment, research, and the enormous computational cost of training and running increasingly sophisticated models. For investors, this created a powerful story. The more AI expanded, the more chips companies would need, the more data centers would have to be built, and the more valuable the companies supplying this infrastructure could become. But there was one problem with this entire strategy: China was being forced to play the game with fewer resources. Chinese companies faced restrictions on access to some of the most advanced American chips. They had less access to the enormous pools of capital available to the biggest American technology companies, and they were operating under semiconductor constraints that seemed, at first, to make direct competition almost impossible. If America could spend hundreds of billions of dollars building an enormous AI infrastructure advantage, how could Chinese companies possibly compete? The answer was surprisingly simple. Instead of trying to win the same game, Chinese researchers increasingly began looking for ways to change the economics of the game itself. The turning point came in early 2025 when the Chinese startup DeepSeek released its R1 reasoning model. What made R1 so important was not simply that it was capable, but that it demonstrated how much AI performance could potentially be achieved without following the assumption that every improvement requires an enormous increase in computing power. DeepSeek also released its model openly, allowing developers around the world to experiment with it and build on top of it. The reaction from financial markets was immediate because investors suddenly had to consider a possibility that could threaten one of the most important assumptions behind the AI investment boom. What happens if powerful AI becomes dramatically more efficient? That question was enough to trigger one of the most dramatic market reactions in the history of the AI industry. Nvidia lost roughly $593 billion in market value in a single day, while technology stocks across the market suffered major losses. The reason was not that DeepSeek had suddenly destroyed Nvidia or proven that American AI companies were obsolete. The real problem was that investors had to rethink the amount of computing power that future AI systems might actually require. If companies could achieve similar levels of intelligence with fewer GPUs, more efficient architectures, and cheaper inference, then perhaps the world would not need to spend quite as much money on AI infrastructure as investors had previously assumed. This became known as the DeepSeek moment, but the deeper story was only beginning because DeepSeek was not an isolated event. It was an early example of a broader Chinese strategy focused on efficiency, openness, and mass adoption. One of the most important technologies behind this shift is called Mixture of Experts, or MO. To understand why it matters, imagine a huge company containing hundreds of highly specialized experts. If a customer asks a simple question about finance, you would not need every expert in the company to work on that question. You would simply send the problem to the specialists who are most relevant. Modern AI models can work in a similar way. Instead of activating every parameter every time a user sends a request, the system can selectively activate only a portion of the model. This means that a model can contain an enormous number of parameters while using only a fraction of them for each individual task, dramatically improving computational efficiency. And this is where the scale of China's latest models becomes particularly interesting. In 2026, Moonshot AI introduced Kimi K3, a model reported to contain around 2.8 trillion parameters and to use a mixture of experts architecture in which only a portion of those parameters are activated for each task. The important point is not simply that China built a massive model. The important point is that China is increasingly demonstrating that massive models do not necessarily have to operate with massive computational costs for every single request. This represents a subtle but important shift in the philosophy of AI development. The American strategy has largely been built around scaling: more GPUs, more data, more training, more electricity, more capital, and increasingly larger models. Chinese companies are increasingly exploring a complementary strategy in which the objective is not simply to build bigger systems, but to extract more intelligence from every unit of computing power. Better architecture, sparse activation, efficient inference, model optimization, and lower operating costs become just as important as raw scale. In other words, China is not necessarily abandoning the race for bigger models. It is trying to make every dollar and every chip go further. And this leads to another major difference between the two ecosystems: open weights. Many of the most powerful American AI systems operate primarily as closed services. Users interact with them through applications or APIs, while the underlying models remain controlled by the companies that created them. This is a highly attractive business model because every developer and every company that uses the model can generate recurring revenue for the provider. But Chinese companies have increasingly embraced a different approach by releasing model weights that developers can download, deploy on their own infrastructure, customize, and build products around. Economically, this changes the equation because a developer no longer necessarily has to pay a large company every time an AI system performs a task. If the model can be downloaded and operated locally, the company using it can potentially reduce costs, maintain greater control, customize the system, and avoid becoming completely dependent on a single AI provider. Imagine two companies competing for the same customers. The first company offers the most powerful AI model in the world, but every request costs money and the customer must rely on the company's infrastructure. The second company offers a model that is slightly less powerful but is open, inexpensive, customizable, and can be deployed on the customer's own infrastructure. For a giant corporation with enormous resources, the first option may still be attractive. But for a startup, an independent developer, or a company operating under tight budgets, the second option can become incredibly compelling. And this is where the idea of AI commoditization becomes so important. The biggest fear for American investors may not actually be that China will build an AI model that is dramatically better than America's best models. The bigger fear is that Chinese companies could help create models that are good enough to eliminate the economic premium associated with the most expensive systems. Imagine spending $100 billion building an enormous AI infrastructure capable of producing the world's most advanced models, only to discover that another company can offer a system delivering 90 or 95% of the practical value for a tiny fraction of the cost. Your technology may still be superior, but your economic advantage becomes much harder to defend. Customers begin asking a simple question: why should I pay 10 times more for a model that is only slightly better? Once enough customers start asking that question, the market changes. AI begins to behave less like a luxury product and more like a commodity, where price, availability, speed, and efficiency become increasingly important. This is one reason Chinese models such as Alibaba's Qwen, DeepSeek, Kimi, GLM, and other emerging systems have attracted so much attention from developers. Their importance is not simply measured by benchmark scores. It is also measured by how many developers actually choose to use them. Platforms such as OpenRouter have provided a useful window into real-world demand, showing that Chinese models can compete directly with American models in actual usage, especially when price becomes an important factor. Developers often do not need the absolute best model in the world. They need a model that is good enough, fast enough, cheap enough, and flexible enough to help them build something useful. If an open model can provide that combination, it can become part of a developer's workflow very quickly. But this is where we need to be careful, because saying that China has defeated America in AI would be misleading. The United States still has enormous advantages in semiconductor technology, cloud infrastructure, research talent, capital, and access to some of the most advanced computing systems in the world. American companies continue to produce extremely powerful models, and in several important areas they remain ahead of their Chinese competitors. The real story is therefore not that China has suddenly become technologically superior to America. The more interesting story is that China may be making technological superiority less economically valuable. If an American model is somewhat better but costs dramatically more to operate, while a Chinese model delivers almost the same practical results at a fraction of the price, the technological lead remains real, but the economic value of that lead becomes smaller. And this is where the semiconductor restrictions create one of the most interesting paradoxes in the entire story. The United States has spent years restricting China's access to some of the world's most advanced AI chips because policymakers wanted to slow China's ability to develop cutting-edge artificial intelligence. These restrictions have absolutely created serious challenges for Chinese companies, particularly around advanced GPUs and high-bandwidth memory, and China still faces major bottlenecks in semiconductor manufacturing and AI hardware. But restrictions can also create incentives. When you cannot simply solve a problem by buying more computing power, you are forced to find ways to get more performance from the resources you already have. Scarcity becomes a forcing function for innovation. If you have unlimited resources, you can brute force a problem. If resources are limited, you have a stronger reason to become more efficient. This may be one of the great ironies of the current AI race. American restrictions were designed to make it harder for China to compete, but they may also have encouraged Chinese researchers to focus intensely on efficiency, optimization, and alternative architectures. The result is not that China suddenly has unlimited computing power. It does not. The result is that Chinese companies have developed strong incentives to ask a different question from their American competitors: how much intelligence can we extract from every chip, every watt of electricity, and every dollar we spend? That question could become extremely important as AI scales around the world. Because the next phase of the AI race may not be about who has the smartest model. It may be about who can distribute intelligence most efficiently. For years, advanced AI was scarce. The best models were controlled by a small number of companies, the best chips were difficult to obtain, and access to large-scale computing was extremely expensive. But if open models continue improving, the economics begin to change. A startup no longer needs to build its own billion-dollar AI laboratory just to create an intelligent product. It can take an existing model, customize it, connect it to its own data, run it on its own infrastructure, and compete with companies that have vastly larger budgets.